Hey there, thanks for taking the time to check out the GitLab Access Manager demo for this week. Let's get started. So this week we're going to focus on the 1.11.4, which is using calendar versioning. The iteration is including the schema design and SQL migrations, the models and relationships, and we're going to specifically look at the Auth and Saas namespaces. What that really means behind the scenes is we're looking at how we're handling all of our users, what the data that comes in from Okta, how we assign them to groups based on the departments, department groups, managers, and other attribute metadata. And then looking at the Saas namespace, we're looking at all the tech stack applications that we have and how we need to set up our scaffolding in our database in order to store not only the data we have about our tech stack, but how we associate our users with those applications, which groups and roles they have access to, or any of the entities that each of those applications may have. So let's have a look and see what we got under the hood. So to get started, let's look at the schema design for the Auth namespace. And what this is really focusing on is how do we capture data out of Okta? And so in our case, our Auth provider is Okta. We could use any single source of truth or any single sign-on provider, but the Auth provider that we are using has data about each of our employees and our contractors, most of it which is fed from Bamboo HR and soon to be Workday. So our goal is to import the data from Okta and use that metadata to map to all of our different groups and roles. So if the Auth provider is Okta, how do we set it up to recognize what data we need from the Okta profile? Well, the first step that we can use is what's called an Auth provider field. And we'll look at the details of that in a few minutes. But essentially that says if the job title of this user is Senior IT Systems Engineer, I can then map that from my Okta profile over into my GitLab Access Manager user profile. The same thing applies with groups, and this looks for certain attributes. And so for example, a department attribute, and we'll map it and say, if I belong under information technology, I would like to automatically map you to that group. That group may have downstream impacts to what roles you get access to, what applications you can request access to, and all sorts of approval and action flows that follow that. Now, auth groups are a much more powerful thing than they might seem. It's more than just you belong to a member of a group. They're used as part of our role-based access control mechanisms. And so the groups impact with the roles, with the users, and then we also have the idea of service accounts. We're not going to spend any time looking at that today, but that simply allows our other systems to integrate with GLAM for bringing data in and out, right? Okay, so let's dive under the hood of what this schema actually looks like. So from the provider perspective, we mentioned a moment ago we're going to dive into the fields. What it essentially looks like is at the provider level, what key is it providing? So I mentioned a job title. The job title will map to the title inside of our database, right? And then over on the groups, it's looking at a couple different things. So the first, it's going to ask which provider is it? We know that already. Which group are we going to provide access to? And then what type is it? And this is going to be one of two options right now. The first is a default. So every user who has this value is going to be mapped, or with a meta key. And what the meta key is looking at is that attribute, right? And then if it's a certain value, then map to this group. The other thing that we have as well as part of our new audit system is the ability to have an approval flow tied to it. And this simply says, in order for this group to get automatic access, or these users get automatic access to this group, this is the approval flow that everyone in the approval chain is signed off on. So we can audit trail back all of our automatic mappings without the need for manual access requests. There's a lot more power under the hood with that. We're not going to spend any further time today looking at that though. As you drill down from the auth provider, we have our auth users table. I mentioned a moment ago that job title, that's where that's coming in here. We have other data that looks very reminiscent of if you had a local user authentication system. Ours is very similar in that, right? We don't need to have all these fields. However, it gives us a lot more control in terms of what we can access, how we can manage different two-factor authentication. Although we use Okta for sign-in, there may be other aspects that we want to put more security controls in place, since this does give a little bit of a keys to the kingdom type of system. So we have all the security options in place. We can choose to turn them on, and we'll figure that out as we go through the implementation. Now, looking at groups, this simply shows how we map users to groups. So we saw a moment ago how users can automatically be mapped based on the metadata they have from Okta. The other way we can do it is by manually requesting access inside of the GitLab Access Manager UI. When that happens, that same approval flow is going to apply. Now, it may be one where if you're a member of a certain group, you get access a little bit easier than other members might be more of exception security, overrides and approvals and such. But this is where it maps to it. One of the new benefits that we're going to be introducing is the expiration and audits. And what that basically says is that you're going to get access for a period of time, and your approval flow has an audit after number of days built into it. So for example, you may get access for 180 or 365 days before the security team or your manager or another person in the company is going to look at that data. Or we can set an expiration date. This is going to be very helpful when we need to do short-lived credentials. So for example, you're helping respond on some incident. You may only need 24 hours of access. The expires that allows us to grant access and then revoke it at the same time or shortly thereafter. And that gives us the power to do short-lived credentials and not leave access out there long-standing. And although we're not covering it today, that's where a lot of our back-end action scripts and action chains come in, where you can provision your user account or access if it's SAML-oriented, or revoke it just as easily. So we get a lot more control of the automation on the provisioning and deprovisioning without any human intervention on a system administrator side. That's one of the big power benefits of what GLAM can do. So that's how users and groups work. If we take a step back and look at how providers fit in and how the groups fit in, we mentioned service accounts. You can see those here if you're interested. All the auth roles that we see here are basically the different abilities for you to access areas of GitLab Access Manager. For the most part, most users are going to have a pretty restricted view to just their roles, their groups, and any access that they have. We can grant additional roles depending on the different security roles that a person may have at the company, IT administrators, system owners, things of that nature, and do a lot more granular elements. And the permissions that we go down to are both for a web user interface, which pages that you can access, as well as the API, which endpoints that you can access. We'll put data scoping in at a later point in time. But for right now, this introduces a lot more benefits of a least privilege model than what we have today. So that's the Auth namespace, right? We'll jump over and look at the Saas namespace. So our Saas namespace is focused on a couple different things, but there might be some confusion about the terminology. So Saas itself is looking at basically our tech stack applications. Now, each tech stack application is going to be a little bit different, right, in what they call things, what we're trying to give access to. And a big part of what we have to do a lot of our design challenge in this, and this is where the GLAM design is a little trickier and a little more ambiguous at first glance, but there's a lot more power under the hood. So let's take, for example, 1Password. 1Password has vaults, it has groups, it has users, but not every tech stack application has vaults. So why would we create a database table called Saas Provider Vaults? It wouldn't make any sense. It's only used for that one application and we have 170 plus. So what we end up doing is introduce the idea of an entity. And the entity is kind of a universal term for, is it a vault? Is it a group? Is it a license? Is it whatever it is? Think of how your applications, if you're a system owner, are set up today. What are you granting access to? If we look at it maybe more broadly, or maybe something universal that everyone would understand today, what about GitLab groups or GitLab projects? Maybe there's a GitLab project that you need access to that has restricted membership to it. That allows us the ability to say the entity would be the GitLab project, or maybe it's a GitLab group over top of it. We would then grant access to a certain group of users or a specific user through the Saas instance group or Saas instance users. And that gives us the different overlays and controls while maintaining a very simple database structure and allowing a lot more of almost a polymorphic database relationship, if you will, to allow us to control that. And that brings us more in the benefits of, in the Google Workspace, we can do Google Drives, but we don't have to do any changes to our database architecture. So that's where entities come in. Everything that you see on this slide is what we're basically mirroring the metadata that we can get from the API of each of these SaaS providers or tech stack application providers. So the groups, this isn't the groups that we think about them in GLAM, it's the groups that they actually have in their system. So we may have auth groups on our side, what we mapped our users to. The groups themselves are what would actually be showing up. So a really good example of this may be Google Groups. In Google, we have a group and we have members. we would actually create a group in Google, and it would show up as a Saas instance group. It may also show up as a Saas instance entity from an approval perspective. Don't worry about the details of that. We'll take care of that. The Saas instance users then get mapped into that group, and that group has rights. So when you think about GCP, when we map access to a GCP project for a large group of users, we'll use groups instead of mapping each user individually. This is how you would get access to that group and then grant the group access to that entity, and the entity would be the GCP project. So those are some of the complexities. We don't want to spend too much time more going into them today, but it just gives you some of the design thinking that goes into why we're doing what we're doing here. So one of the things that we're going to run into is we have a lot of variances. We have a lot of different system administrators across the company, a lot of different owners and departments are doing different things. We may call something different. So we have a SaaS provider, and that is essentially the company that provides the service. Now that could be something very simple. It could be Google Workspace, our G Suite, if you will. That is providing a service to us. Do we have multiple accounts in Google? And that's where SaaS instances come in. So today it's the GitLab.com organization. Okay, that's pretty easy. There's one instance. Every SaaS provider is going to have a default instance. But what if you have more? So in AWS, the SaaS provider would be Amazon Web Services. But the SaaS instance would be each of the AWS accounts that we're then granting access to that have their own identity and access management elements to them that are isolated from each other. So this gives us a scalability model, right? Now, at a business metadata level, what if we want to bucket and categorize things in different ways? So in a normal parent-child relationship, a provider can only have one category. Well, what if the IT team wants to categorize things differently? What if the security compliance team wants to categorize things differently? What if the different business owners think about it differently? And so this gives us the ability to use multiple categories for each provider and have a lot more of a many-to-many relationship going on. We don't need to worry about the details, only that we're building in a lot of the flexibility because naming things is hard and not everyone's going to agree on that. This gives us the flexibility of everything has a unified identifier and all the database is already built to support that, where we can put aliases and names and allow people to organize things in a way that's more human-friendly without having to have challenges with different system iterations and variances that can really cause problems down the road. So that's what SaaS categories, providers, and instances are all about, right? As we go down under the SaaS instance, what we're then seeing are each of the things that are configured there. So we mentioned this a little bit about the different entities that are underneath it. This simply shows you more of the fields that we're going to capture on our side when we create that. And so anytime that you see the row or column, I should say, for API metadata, that says, okay, we know that we're either creating a new group on that SaaS instance, or we are going to import an existing one. When we get data back from their API, whatever vendor it is, this is where we store it. Now there may be additional information that we as a business want to put in. And that's what the biz metadata field is for in various tables. That allows us to put our own metadata inside of it, and we're keeping the data structure separate so that data is not going to get overwritten, right? And so think of the API metadata as our system data, and the biz metadata as what we define it as a human-friendly way. In many respects, this could be things where some of the access provisioning notes go in, different things and elements that could put in there by the system owners. Various things can get added there. It just gives us the flexibility for storing it. Everything else that you see here is simply mapping that information across. And as you go over to SaaS instance users, every system treats a user a little bit differently. Some have a shared SSO account for their service, and it gets then invited as a member into different organizations. Others have local IAM accounts. Others use SAML. Others have Okta integrations. This table here allows us to track all those variances in one place, and we'll simply use the fields that apply depending on what the SaaS instance or SaaS provider is. So those are different flexibilities that we have. The only other thing I want to draw your attention to for today, to keep an eye out for future demos, is the expires at, provisioned at, and unprovisioned at. And this is allowing us to track that life cycle of a user. So GLAM is a lot more than just getting you access. It's tracking how long do you have access. When it's time to offboard, or if you're going to change roles, we automate the entire workflow of removing your user account, or removing your resources, or unmapping your permissions if you move to a different role that has different permission sets. So we have a lot of flexibility, and so the database schema design we're doing today is laying a very strong foundational groundwork for everything we're doing in the future. Make sense? Cool. So there's a lot of roles and users that map into here. We're not going to worry too much about this other than saying that the roles are what each of the SaaS providers call them. We're not defining anything special here. In many cases, a person is simply a member or user, a manager, maybe an owner. There's usually about 5 roles that most SaaS providers have. We're simply adding those into our database so we know how the role mapping works and having a local cache to be able to do all the relationships that you can see a lot of the lines and interdependencies here. Now, if there's more complex scenarios, Amazon Web Services is one that comes to mind because that's what I deal with a lot, is there are hundreds, if not thousands, of roles in there. Same thing for GCP and some others that are just a little more complicated. Salesforce.com could be another one. That allows us a lot of flexibility to add in and then map it, so we're not having to do a lot of different work in different providers. We bring a lot of the legwork into our side, and we know what to choose from a drop-down menu, and we create that unified user experience. And similar to how GitLab is the single DevOps platform, this is the single access management platform. We're bringing all the pieces together so we do all the talking, and all you have to do is go to a single UI and get access. So that's what we're looking at. Those are the different pieces. And then at the SaaS and instance entity level, we mentioned this earlier, we're not going to dwell on it too much further, only that there's going to be different variances that we're going to discover as we start working with the different SaaS providers and what we're trying to integrate. But for all the tech stack apps that we've looked at so far, this model should work pretty well for us. So there's that. That's how that works. And then we can also do a lot of the group mappings. Again, we're not going to spend a lot of time on it. Just simply know that we can map into each entity what group it has. And so going back to our earlier 1Password example, we can map a group of engineers into something. Or maybe you're trying to use Teleport to do SSH access and you're an engineer into our systems. You need to be a member of a certain group in order to use Teleport. And so there's different elements that get into this, and this is where this all gets mapped at, right? So taking a step back, what we're looking at here is our SaaS providers. Each SaaS provider can multiple SaaS instances. And if you're still confused about what a SaaS instance is, think about it with the URL. So what URL are you signing into? And so we're simply, there's multiple URLs, maybe there's a production and a staging, you'd have 2 instances. And we're granting access to production and staging as instance A or instance B, if you will, right? And then obviously all of our instance groups, users, roles, and the entities that we saw down below. So that's what the Saas namespace is all about, right? It's tracking all the tech stack apps and all the IAM and RBAC interdependencies within that sphere and that world, if you will. All right, so let's do a little bit of a demo. And what I want to show you is just some of the code behind the scenes. We're not going to take too much time, it just kind of gives you a taste. We're going to look at migrations, and all migration it's a SQL schema file that our framework looks at, right? We're then going to look at models, and what model simply does is it says, here's the definition of how the schema is defined, here's the relationships in which I'm going to connect to the other models, and then we're going to look at how that data schema looks when we actually bring data into it and look at our SQL database. What we're going to see later, in future demos, is how we'll use that data. But for data, let's just look at how data looks inside of these schemas, right? All right, so let's bounce over here and look at the migrations. And so in our application here, we have our app, GitLab Access Manager app, and down here we have database migrations. And if we look at auth provider groups, this is when we mentioned earlier about how a user is going to get access to a group depending on a value they have from their Okta metadata. And so we saw the schema and some of the different pieces in the slides. This is what it looks like in the code. And all that we're simply doing is specifying we're going to create a new database table called auth provider groups. Okay, easy enough. We're then going to give it all the different types of fields, any constraints, and all the different values that we might need to have, right? All of our foreign keys in our database use the UUIDs, right? So no problem there. And then we'll simply do the type. Remember before I mentioned default and meta? So in this case, most of the things we're going to do are meta. Great, fantastic. As we create different keys, it's going to look and say, create a group and then specify the key that's looking. In this case, it might be GL_department. The meta value might be information technology. It might be engineering development. It could be engineering support. Could be sales. Could be customer success. Any of the different departments will have different groups corresponding to them, right? So that's pretty easy. That's the way that that works. When we map that provider group over to a model, this is a little more of the behind the scenes magic. As a user, you'll never see this. You don't care about this. This is just showing the engineering and the process that we go through in order to make this all possible. There's a model for Auth provider group, and we simply tell it what database table are we looking at? Great. What fields can we fill in? And although there may be multiple columns that are in there, they aren't ones that the user should be able to fill in from either a web form or in the dropdown or maybe an API request. They're things that we manipulate in our system, right? And so the things that you can pass in is, which provider is this for? That's going to be the ID of our Okta provider in most cases for us. Which auth group is? We previously create the auth group that we're trying to map the users to. The type, remember that default or meta, and then the meta key and the meta value are what we're actually looking for inside of the Okta metadata, right? We then have the ability to control all our validation rules. This is where it's checking to see if the inputs are provided by the user, either in a web form, if someone's trying to do some CSRF, or any of the other aspects or API requests. All that goes through these required filters, right? And it just double checks and makes sure that everything is good. So we have store rules and we have update rules. We can customize validation messages. Sometimes the system message isn't quite as friendly to the humans as we would like it to be. So this simply makes sure that we can override it if needed. Now, that's for getting the data into the database, right? That's what the model's defining. We can also define how it comes out. And this is where typecasting comes in. And we simply say, what are the different fields? What format are they going to come out at? For the vast majority of this, you're never going to see or care about this. The important part here is when we deal with API responses, that's where we want to make sure we're giving them the right format. And also if we're dealing with any sort of date-time conversion stuff, sometimes it gets passed in a string, sometimes it's passed as a date-time object. There's different elements that get into there, right? Dates, we can do conversions on that. But the model has a lot more importance, in my opinion, with relationships. And there's different types of relationships. There's parent relationships, there's child relationships, many-to-many, distant child relationships. And this is saying it's telling the model what other database tables can I go talk to, and what are the columns, or what's the foreign key ID that I'm going to go look for. And so in this particular case, for an auth provider group, there's a couple different parent relationships. We can ignore these for just a few minutes, don't worry about it. The auth provider is saying, which provider am I going to care about? This auth provider belongs to the Okta auth provider. Great, no problem, that's easy. When I go to the auth provider's table, I can use the key that I have in my table to go and search that table for the ID. Same thing goes for auth group. And so the auth group itself is saying, go find the auth group for this ID and match it. So this is simply giving the system the way to map what database value and row am I looking for when I go to the other table. That's what parent relationships are all about. Child relationships kind of do the inverse. It's looking at a table and saying, I want to find all records that belong to me, and then use this ID, my ID, to look it up. And so in this example is we can find, hey, here's an auth provider group. I want to find all the team members that have signed in from the information technology team, and I want to find all those users that have been automatically mapped. I will then look at that database value and bring that in, right? So that's what it allows us to do. So that's the parent relationships, child relationships. A lot of this is kind of fundamental to object-oriented programming and some of the things that it doesn't matter what language you use or what framework you use. The fundamentals are all the same, generally speaking, when it comes to this sort of thing. But for those of you who've never seen it, it just helps to kind of paint a picture of things where if you've only ever seen YAML files or you've only been doing Markdown or Excel, this kind of gives you a little bit of an intro to how we do database work, right? And how we try to connect the dots. So that's what that's all about, right? And there's different many-to-many relationships. The deeper that we get into our different models, the more that you're going to see a lot more of that. We're not going to spend a lot of time going into that today, right? There's also the users table. I'm not going to spend a lot of time demoing through this specifically, but it simply gives you a little more of the complex nature of the different fields we have, how we can work through it. And at the model level, there's more things that we manipulate, right? Because the user is the core of what we're trying to do, right? It's what we're trying to grant access to. It's what we're trying to give approvals for. So there's a lot of different elements that we have and we can control through this. And so it just kind of gives you an overview, a taste, right, of what we can and what we can't do. And so that's kind of how we set this up, right? So there's where we look at from, here's how migrations work, here's how models work. There's a lot more coming, and you can see the roadmap for the other pieces that build on top of it with services to manipulate that data, API to consume that data, web UIs to see dashboards, look at lists, create forms. All those pieces are coming. But these are the building blocks that we use to get there. So this is just demos focusing on, here's the building blocks of this week and what we've been building. So let's do one final thing, and let's look in our database ourselves. So I've just done an import of some of the values that are in here. We don't have the full manipulation ability yet, but we were able to fork off of some other code that we've written in the past to bring some data in to show you how this works. And so for auth provider groups, you can see here that we've got a couple different groups going on. It doesn't matter what the group ID is for the moment, right? The meta key itself, we're looking for Okta to look at the GL division. If the value is engineering, then map that user to this group, right? Simple enough. If the value is GL department, or the meta key is GL department, the value is customer support, map it to that group. And it will simply loop through all the groups and see which ones you match. It's that simple, maps you to it, right? And where that helps at is when you end up over in auth users, you can see, if we go ahead and we look at just my profile, over on the right-hand side, if you look at the red JSON, the provider metadata, this is what Okta knows about me. And so this is where it's grabbing, hey, my department is business technology. If I find a value for business technology, what group am I going to map to? And this does a lot of the legwork from role-based entitlements. We are introducing one additional layer deeper called department groups, which we're inheriting from our infrastructure standards. And what that allows us to do is go a level below it and say business technology is a department, and then IT engineering is the sub-department or department group, if you will, right? And so those different elements allow us to map a lot of pieces. One other trick that we do have as well is we are going to use auth provider groups for managers. So for those where we don't have enough information schema behind the scenes of what groups we have at GitLab, which is a challenge we have right now. We're iterating, we're getting better, but we can actually use the manager name or the manager email address or the manager ID to do a lookup and say, if your manager is Peter, in my case, then map automatically to IT engineering. If your manager is someone else in the engineering development organization, then automatically map to the manage access import group. All these different kinds of things are ways that we can do that. So there's a lot of power under the hood here. We built a lot of universal, a lot of dynamic abilities to do this. So that's where we're going, right? We're bringing a lot of the data schemas to this that we haven't had before, and we're not worrying as much about static YAML files and merge requests and some of the Git mentality. We're trying to build the right tool for the job. And the biggest thing that we're facing today is we're getting asked, well, aren't there better SSO and IAM solutions out there? There are many that are out there. However, the compatibility across the wide variety of tech stack applications that we have, we'd always be selling ourselves short. We have 170 plus tech stack applications that we pay for. We're well over 200 that we have with open source integrations. So what we want to be able to do is if you build it, you get what you want. If you buy it, you get 70% of it, and you have to live with the consequences. So our goal ultimately is to build the right platform for GitLab and all the universal elements of the things we have to deal with at GitLab. So there you go. That's what we're doing with our database schema so far. Additional things are coming with the action and the approval flows. That'll be following up in a future demo. But for today, that's what we got to share with you. So thank you so much for that. And with that, if you'd like any additional reference links, or you want to browse this code or have a look at some of the more of the explanation of the documentation around it, feel free to check out these links. And with that, thank you so much and have a great rest of your day.